3y equals negative 1.9. The second equation is 2x minus 7y equals 3.3. We're going to use substitution. I'm going to say it's probably the easiest style for solving the points of interest between x and y. So, I'm going to take the first equation and I'm going to set it equal to y. Okay? I'm just choosing one. By looking at it, there probably is no extremely easy one. They're all going to be roughly the same difficulty. I have to use the same amount of steps. So, first question. First equation. 4x plus 3y negative 1.9. And I set this one equal to y. So, when I move 4x to the other side, it becomes negative. Now I still have to isolate y, so I'm going to have to divide every number by 3 to get y by itself. Y will equal negative 1.9 over 3, subtract 4 over 3x. If you like, you could turn both of those into decimals. I like working with fractions. I'm going to keep them as fractions. So you'll see how to do it as a fraction, okay? So now that I have y is equal to an algebraic expression, I'm going to take the second equation, two x minus 7y equals 3. 2x minus 7y 3.3. I'm going to substitute my algebraic expression into the y in the other equation, the second equation. We plug this in, it'll look like this. 2x minus 7 negative 1.9 over 3 minus 4 over 3x equals 3.3. Okay, so part of this is in fractions, part of it's whole numbers. We're going to have to do some fraction work along with this. Okay, guys?
Yes.
So I have to distribute a negative 7. That means I have to multiply negative 7 by the fraction negative 1.9 over 3. And I also have to multiply negative 7 by the fraction negative 4 over 3. I'll do it on the side for you guys so you can see what it looks like. Negative 7 as a fraction is negative 7 over 1 times negative 1.9 over 3. When we multiply these fractions, the bottom will become 3. 1 times 3 is 3. The top will become positive 13.3. So negative 7 times negative 1.9 is 13.3. So I'm going to leave it as a fraction still. Our very first one's going to be 2x plus, and it becomes positive because I multiplied a negative times a negative. 13.3 over 3. When we distribute the negative 7 times negative 4 over 3, negative 7 once again is a fraction, is negative 7 over 1 times negative 4 over 3. Again, we're multiplying two negatives, so we have a positive answer. 3 times 1 is 3. Negative 7 times negative 4 is positive 28. So, I'm going to have plus 28 over 3x is equal to 3.3. Plugged it in. Now I've distributed everything.
Ding, ding, ding,
All right.
ding, ding, ding.
So we've distributed negative 7. I need to collect like terms. My two like terms, 2x, 28 over 3x. So I need to add those together. One's a fraction, one's not. I'm going to get a common denominator again. So I need to turn the 2x to a common denominator. I'll do it on the side in blue. 2 over, now I need to make it a 3 as our common denominator because it's a 3 with 28 over 3. So that means I'm going to have to multiply 2 over 1, the top of it and the bottom by 3, 6 over 3. So now, our equation is going to read a little different. It's going to say 6 over 3x plus 13.3 over 3 plus 28 over 3x equals 3.3. Okay, now I can add my like terms. I can add 6 over 3x plus 28 over 3x. Again, we'll do it on the side. 6 over 3 plus 28 over 3 is going to equal to 34 over 3. So now that I combine my like terms, I'm going to have 34 over 3x plus 13.3 over 3 is equal to 3.3. Okay? I need to move 13.3 over 3 to the other side of the equation. 34 over 3x is equal to 3.3 minus 13.3 over 3. Same idea.
Let's keep the over
If I
3.
combine those, I need a common denominator again. Okay? So I need to turn 3.3
Multiply by
into a fraction, which is 3.3 over 1. I need a common denominator of 3 because 13.3 is above 3. So that means I need to multiply the top of this fraction by 3 and the bottom by 3. I'm going to end up with 9.9 over 3 as my new number. So 34 over 3x equals 9.9 over 3 minus 13.3 over 3. Lots of fraction work for that. We'll do it on the side.
I'm not getting how the 13.3 becomes 3.3 over 1.
Damn. It's funny how you spell chalice.
So, now that I have that, I can subtract the two. 9.9 minus 13.3 is going to be negative 3.4. So, 34 over 3x equals negative 3.4 over 3. Just so you understand. Okay? Now that I have this, I'm going to isolate x. This is where it gets tricky. Okay? Isolate x, I have a fraction. Okay? I'm going to ask you guys if any of you know how to do this.
Quiet, man.
So, we're going to multiply this entire
Hey,
equation.
shut up.
So both numbers by 3. When I multiply by 3, this is our fraction. We're going to cancel out. So I'm going to be left with 34x is equal to negative 3.4. Makes it much simpler to look at. Okay? Now that I have that, I got to isolate x. So I got to divide this side by 34 and this side by 34. That will become x is equal to negative 3.4 over 34. So I can leave it as that fraction, or I can put it into decimal form. Okay, so in decimal form, x is equal to negative 0.1. It's a little easier to look at with the fraction. After all that work, we only solved one variable.
Oh my god.
We still have to plug this in and solve for y.
No, that is all easy.
All that?
All of that, buddy.
Then the rest
We're going to take one of these equations. We'll take the first one. 4x plus 3y equals negative 1.9.
So you plug in 4 times 0, 0, 1.
No, look.
Oh, someone's writing?
I swear to God, it's still recording.
Sir, is it recording right now?
Yeah, it is.
So read me the second equation. 4x
So it's still
4x
recording.
plus 3y. 4x plus negative 1.9. So now that I have a value for x, I can plug that in for the x in our other equation. So, 4 negative 0.1 plus 3y equals negative 1.9. And multiply this, it becomes negative 0.4. And move that to the other side. 3y equals negative 1.4 plus 0.4. 3y equals negative 1.5. I divide both sides by 3. Y equals negative 0.5. So our point of intersection, the y was much easier to solve once we had it valued. Our point of intersection is going to be negative 0.1 and negative 0.5. Our x value and our y value. So, a lot of work all together.
That was easy.
That'll be one of the more difficult type questions that you guys
Sorry,
will
I've
have
never seen
to
a
solve.
question that long.
Okay, question 16, page 49. Question says one type of fertilizer is 30% nitrogen, the second type is 15% nitrogen. If a farmer needs 600 kilos of fertilizer, that is 20% nitrogen, how much of each type should the farmer mix together? So this is a let. We need to start with our let statements. We're going to use x and y. Let x equal 30% nitrogen, so that's our solution for that. Let y let y equal our 15% solution. Nitrogen, that is 15%. So, I have an x and I have a y. I know altogether that I need 600 kilograms. So I need a certain amount of x and a certain amount of y to add up to 600 kilograms. That's our very first linear equation. Certain amount of x plus y is going to equal 600. The second equation, though, we're going to be multiplying. We're trying to figure out an actual percentage of that 600 kilos that needs to be 20%. So, I know that I have 600 kilos, and my solution in the end needs to be 20%. 20% as a decimal is 0.2. To make that, we just do 20 over 100, 0.2. I'm going to have to multiply those. When I multiply them, I'm going to have 30, I believe. So, now that I have that, I still have to set up the second part. I need a certain amount of x. Since our x is 30% nitrogen, the coefficient is going to be 0.3. That's 30% as a decimal in front of the x. And I'm going to be adding to 0.15 y, since y represents 15% solution. So my two equations are now x plus y equals 600. I know that altogether I need 600 kilograms. 600 kilos of fertilizer.
Ew,
And I know
man.
that 600
Smells
needs
almost
to be
as bad as
20%
Mickey
solution. So I need to multiply that 600 by that 20% to get what my second equation is going to be equal to. It's going to be equal to exactly 30 kilos of nitrogen. We're getting a pure solution there. 30 kilos of nitrogen, and I know that I need 30% of the first mixture, 15% of the second mixture is going to equal that 30%. So we have our two. You can use elimination, substitution, grafting. That would probably was instructed. Okay? To solve the points of intersection, to tell us exactly how much we need to do. We need a grade error in our multiple math. What is it?
1.9.
120. Sorry, guys.
Yeah, I was doing the mental math. And
Can I go to the washroom?
That didn't add up.
Sure.
Yeah, I know. We gotta fix it all. did it wrong. Yeah, okay, sorry. I did a miscalculation. 600 times 0.2 was 1.5. Okay, so now we have it. We have our two